Number 83. We have a ball, this hollow ball, starts at rest, 2 meters below the surface of a pool. This problem assumes we know a couple densities before we go any further. It assumes that we know the density of water, which is 1,000. Okay, on the quiz or on the test, I'll give you densities. You don't have to memorize them. Density of air is 1.29. Okay, and then we have the radius of this ball. The radius is 0.1 meters, and then we have the mass of the ball. MB for mass of ball, 1 kilogram. Now, what happens here is this. This ball is released from rest underneath the surface of the water. The ball accelerates to the surface. The ball is going to go faster, 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 faster. So let's say that up is plus, down is minus. So as the ball accelerates to the surface, is that a positive acceleration or negative? Positive. The acceleration is positive. Then the ball reaches the surface with some velocity, which we don't know yet. The ball has a velocity, and then it leaves the water and goes up, 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 and for a split second at the maximum height, the velocity is 0. Okay? Now, the acceleration for this second part is what? Is gravity, which is negative 9.8. Okay? So the reason that this problem is in the fluid chapter is because of this acceleration right here. We have to use our knowledge of fluids to figure out the acceleration of the ball while it's in the water. Okay? Once we know that acceleration, the rest of the problem is kinematics. That make sense? Okay, so how do we get this acceleration right here? Let's do it. I'm going to revert this back. Copy these densities down right there. We're going to use those densities. Okay, so we start by doing a free body diagram. We're trying to find the acceleration of the ball while it's in the water. Okay, so what are the forces on the ball? There's obviously a buoyant force. Okay, buoyant force always equals the weight of the displaced fluid. So this will be mass of water times gravity. This is a nice situation because the ball is fully submerged. Okay, now what's the other situation where the ball would be part submerged, part not submerged? Then the volume of the displaced fluid equals the volume of the object submerged. A little more thinking there. Here, look, the volume of this ball is equal to the volume of the displaced water because it's fully submerged. Okay, the other forces. We have mass of ball times gravity, the weight of the ball, where mass of ball is the 1 kilogram. And then you really should include the weight of the air inside the ball, which is mass of air times gravity, because it says right here, it's filled with air. Okay, now why is that a downward force? Well, just think about it. Like, instead of air, what if we filled the ball with water or oil, some sort of oil? Which direction would the weight of the oil be? Down. You know, so same thing with air. You know, air is a substance. It's made up of molecules. So you do mg down for the air. Okay, now we sum the forces. Summing the forces, we get mass of water times gravity minus mass of air times gravity minus mass of ball times gravity. Sum of the forces always equals ma. Now this mass right here, that mass is going to be mass of ball plus mass of air. It's the total mass of this sphere. Okay? Okay, and we're solving for A. So I'm going to factor the G out, clean this up a little bit. So when you solve this equation here for A, you're going to get A. So factoring the G out, mass of water minus mass of air, mass of ball, divided by mass of ball plus mass of air. Okay, we got to solve for two masses. Before we can do this equation, there's two things we got to find. We got to find the mass of the water, and we got to find the mass of the air. Okay, so What's the density equation? Density is mass over volume, so mass equals density times volume. So the mass of the water is going to be density of water times volume of water. The mass of the air is going to be density of air times volume of air. So we got to find the volume of the sphere. Fluids are definitely tedious. A lot of things to do. So can we figure out the volume of this sphere? Yeah. What's the equation for volume of a sphere? 4/3 pi r cubed. The radius is 0.1, so you plug into that equation and you get 0.00419 cubic meters. That's the volume of the sphere. Okay, so mass of water, it's going to be 1,000 kilograms per cubic meter times the volume, 0.00419. Okay, and then mass of air is going to be 1.29 kilogram per cubic meter times 0.00419. So we end up with mass of water equal to 4.19. And then mass of air is 0.0054. Basically negligible. The mass of the air is not really going to do anything in this problem. Okay, so we take all these numbers, plug them in, right? So we have all the values. So gravity is 9.8, mass of the water 4.19, mass of the air 0.005, mass of the ball is 1 kilogram. Okay, so when you plug into this, you get an acceleration of 31.04. Okay? So now, any questions with this? That's the chapter 9 part. The rest of this problem is kinematics. Okay, so can I revert this? Can I clean this up? Okay, so the ball starts here. V initial is 0. As the ball moves to the surface, the acceleration is positive 31.04 meter per second squared. So, and then the distance it travels is 2 meters. So when the ball reaches the surface, we can find the velocity. How do we get that velocity? Vf squared equals V initial squared plus 2ax. V initial was 0. So when you plug, so Vf is going to be square root 2ax. Here's the a, here's the x. You plug in. What you get is 11.14. So this velocity here is 11.14 meter per second. Then the ball goes up, 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 reaches a maximum height. At the maximum height, V final is 0. And what we're solving for is this distance here, right? So we can use the same kinematic, using the same motion equation. So we go Vf squared equals V initial squared plus 2ax. What's V final at the top? 0. We now have V initial for the second part. Ooh, what's the acceleration? It's gravity, negative 9.8, right? So now we solve for x. X will be negative V initial squared over 2a. So that's negative 11.14. We're almost done. Acceleration's negative 9.8, so the negatives cancel, and we get the answer, which I believe is about 6.3. Is that right? Let's see, hold on. Yeah, 6.3 meters.